Namaste, this is Manohar P. Hiramat from Sri Venkateswara College of Engineering. In this video, I'm going to discuss about role of modulation technique in wireless communication system. So let's understand through a video. In this video, we are going to learn the basic modulation techniques and see how they are applied in modern cellular and communication technology. Frequency and wavelength of a wave are inversely connected. Humans have the capability to hear the sound frequency from 20 Hz to 20 kHz. But if a radio tower transmits an electromagnetic waves of the same frequency, the size of the antennas required will be very high. The size of the antenna is proportional to the wavelength. If we have transmitted electromagnetic wave and the same frequency of sound, the antenna's size required would have been in the range of kilometers. This is why we need modulation. Before the electromagnetic waves are transmitted, they will be modulated to the very high frequency signal. Here's a simple analogy. Try throwing a piece of paper. It won't go far. Now tie it to the stone and throw it again. The second method is more efficient than the first one. This is exactly how we do modulation. In place of a stone, modulation gives us a high frequency signal known as carrier signal. As we know, any signal has three basic properties called amplitude, frequency and phase. In modulation process, one of the property of carrier signal is varied in accordance with message signal. For example, frequency of carrier signal is varied accordance to the amplitude of message signal. This technique is known as frequency modulation. In the same way, we can also achieve amplitude modulation. Here, the amplitude of the carrier signal is varied based on the value of message signal. The modulation techniques that we have discussed so far are analog types. Analog modulation is susceptible to noise, which degrades the quality of signals. And moreover, in today's electronic instruments, all operations are carried out in digital form, where digital signals are either in ones or zeros. Let's discuss the digital modulation techniques that are currently used. More specifically, let's see how digital bit flows are converted to electromagnetic wave. The first digital technique is amplitude shift keying. Here, based on the digital pulses, the amplitude of the carrier signal is adjusted. High amplitude relates to 1 and low amplitude relates to 0. The next technique is frequency shift keying. Here, based on the value of digital pulses, the frequency of carrier signal is adjusted. High frequency relates to 1 and low frequency relates to 0. The third technique is phase shift keying. Here the phase of the carrier signal is changed by 180 degree when the digital pulses moves from 1 to 0 or 0 to 1. Telecommunications technology is all about increasing data transfer speed and efficiency. But if you use any of the digital modulation techniques explained previously, you wouldn't get the high data transfer speed. However, there is a technique in physics which if we use it means we can practically send 6 bits of information as a single electromagnetic wave. This technology is known as quadrature amplitude modulation. To understand QAM in easy way, let's take two analog signals. The beauty of QAM is that you could modulate these two different signals as a single signal and then transmit the another receiver end. You will be able to separate the original signal, thereby saving bandwidth. In QAM, the first signal is amplitude modulated using a carrier wave. Second signal is also amplitude modulated with a carrier wave of same frequency and then amplitude, but after giving the carrier signal at 90 degree phase shift. Now these two modulated signals are mixed together and form a single signal. We call it as multiplex signal. The interesting fact is, on the receiver side, we can easily separate out original signal from multiplex signal. In the case of digital QAM, a similar approach is used. Here, instead of analog signals, different combination of bits are added together to produce a multiplex signal. Let's see how a 16 QAM works. We know that any form of data is just a collection of ones and zeros. In 16 QAM, we can pack 4 bits together and send it as a single electromagnetic wave. Based on the value of 4 bits, this will have different phase angles and amplitude. This means the phase angle and amplitude of multiplex signal can completely represent 4 bits of data. In 16 QAM, such 16-bit values can be represented by adjusting the phase and amplitude of the multiplex signal. And this single multiplex signal is then used for the transmission. You can see how the different amplitude and phase electromagnetic signals represent various 4 bits of data. Using a similar technique to that used in analog modulation, here the amplitude modulated signals are also mixed and finally single output is produced. As we have seen in this modulation, two carrier signals that are out of phase by 90 degrees are used. Hence the word quadrature is used to refer this technique. Thus, 16 QAM increases the data transfer speed by 4 times. Scientists have even achieved 64 QAM, which is used in 4G communications. 64 QAM uses 6 bits of data at a time. This making the data transfer speed 6 times faster compared to normal modulation technique. The modulation techniques are not restricted to only cellular communication and FM radio, but also have some applications in TV broadcasting, Wi-Fi, optical fibers, etc. At last, I thank you for watching my video. This is Manor P. Hiramat signing off.